Imagine a world that's... Down here, photosynthesis is strictly impossible. There are no plants to capture energy, no warmth to fuel metabolism, entrails, and seemingly no food source to sustain life. Yet, when we ignite the ROV floodlights, we do not reveal a graveyard. We find wandering holothurians, prowling sharks, and vibrant coral gardens. Millions of tons of biomass thrive in the crushing pressure, defying the logic of starvation. How does a thriving ecosystem exist in a place where the primary source of life, light, is strictly forbidden? The deep sea remains Earth's last great wilderness, a silent, pressurized world where light fears to tread. Now, let's dive into the data and uncover the reality hidden in the deep. Energy is the universal currency of life. On the surface, the economy is booming. The sun pours photons into the upper 200 meters, driving the photosynthetic engine of phytoplankton. This epipelagic zone is a chaotic, unlimited buffet where energy is cheap and abundant. As we descend rapidly, the familiar blues of the surface give way to an overwhelming darkness. But as we descend, the economy crashes. Once we cross the thermocline and enter the bathypelagic, the mid-length zone, the water temperature plummets to near freezing, and the pressure mounts to crushing levels. The abyss is gravitationally locked away from the source of all fuel. For decades, early oceanographers believed the deep-sea floor was largely azoic, completely devoid of complex life, simply because the mathematics of energy transfer didn't add up. How could a calorie generated by a diatom at the surface survive a 4-kilometer journey through a gauntlet of hungry mouths in the water column? By surface logic, the deep ocean is not just difficult, it is a metabolic impossibility. Consider the scavengers we find here, the macroid rat tails, the lysianacid amphipods. They are evolved for an environment of extreme scarcity. Their metabolisms are glacial. Their muscles are watery to conserve protein. They are ghosts haunting a world that should not be able to support them. They are waiting for food that physics suggests should never arrive. We are looking at an ecosystem that appears to violate the fundamental laws of thermodynamics, thriving in a closed system with no apparent input. If you look out the viewport of a submersible in the mid-water, it often looks terrifyingly empty. Crystal clear. A void. This clarity terrified early explorers because it signified a lack of life. In the ocean, clear water is usually dead water. It implies that nothing is growing and nothing is dying. But this emptiness is an illusion caused by the scale of our observation. We were looking for schools of fish or forests of kelp. We were looking for the wrong kind of food. The deep isn't surviving on fresh kills or sunlight. It is surviving on the leftovers of a party happening 3 miles above its head. Something must be bridging the gap. There is a physical connection between the sunlit world and the shadow realm, but it is a constant, invisible weather system. Adjust your focus. Stop looking through the water for monsters and look at the water itself. When we stop searching for the large and magnificent, and instead focus on the suspended particulate matter, the void suddenly transforms. In the crushing darkness of the abyss, a blizzard is falling. This is marine snow. This is the antidote to the mystery of the starving deep. This is marine snow. It was named by the explorer William Beebe in the 1930s, who looked out of his bathysphere and saw what looked like a blizzard of white flakes drifting eternally into the dark. But this is not frozen water. It is a continuous rain of death. Marine snow is organic detritus. It is the decomposing remains of the sunlit world above. It is composed of dead phytoplankton, zooplankton exoskeletons, fecal pellets, and dust. To the uninitiated, this sounds like biological waste, a rain of sewage. But in the oceanography of the abyss, this is manna from heaven. Every white flake you see on screen is a dense, caloric battery, charged with solar energy of the surface and delivered via gravity to the bottom. To understand why this system works, and why it is majestic rather than repulsive, we have to analyze the architecture of a single flake. If we were to capture one of these particles and place it under a microscope, we wouldn't see a single piece of trash. We would see a complex ecosystem in microcosm. Far below the sunlit surface, in the crushing darkness of the abyss, lies the marine snow. These are called aggregates. Individual cells of phytoplankton are too light to sink rapidly. They would simply float in the upper currents, decomposing long before they reach the deep. To breach the abyss, they must band together. They are glued by a substance called TEP, transparent exopolymer particles. Think of TEP as biological superglue. It is a sticky, sugary mucus secreted by plankton and bacteria. As these tiny particles collide in the water column, the TEP binds them. A dead diatom but sticks to a fecal pellet. That clump sticks to a grain of sand. A piece of molted shrimp shell gets caught in the mix. As the aggregate grows, it becomes heavier. As it becomes heavier, it falls faster. This is the brilliant physics of the biological pump. By plumping together, this waste cheats the slow decay of the upper ocean. It punches through the thermocline, racing downwards at speeds of up to hundreds of meters per day. It preserves the carbon and the nutrients inside, protecting them from the scavengers in the shallow water, so they can be delivered to the deep. without witnessing a planetary logistics system. But not all snow is created equal. While the background drizzle of small particles sustains the small scavengers, the deep sea has its own form of heavy freight transport. This brings us to one of the most fascinating and bizarre contributors to marine snow, the giant larvation. This is the larvation, a tiny creature capable of building a complex, glowing filter house over a meter wide. These creatures build elaborate houses made of mucus, complex filtration structures that can reach a meter in width. They use these houses to filter food from the water. But these filters eventually get clogged. When that happens, the larvation simply discards the house and builds a new one. This discarded house becomes a nutrient bomb. When a larvation house collapses, it creates a massive pulse of marine snow. It creates a sinker. These structures are loaded with carbon and trapped particles. They plummet rapidly to the seafloor, delivering a sudden, concentrated feast that can sustain a community for months. When we analyze the sediment at the bottom of the ocean, specifically in the abyssal plains, we are reading the history of the surface. We can see layers corresponding to massive phytoplankton blooms from years prior. We can identify the specific season of the surface world just by tasting the mud of the abyss. The deep sea is not disconnected from the sun. It is the sun's shadow, fed by the constant fallout of its energy. This changes how we must view the creatures of the deep. When we see a sea cucumber vacuuming the sediment, or a brittle star sifting through the mud, they are not eating that. They are eating the concentrated history of life above. They are processing the energy that was captured by the sun, processed by algae, beaten by krill, and then packaged into snow. It is a perfect cycle of efficiency. In the ocean, waste is simply energy moving from one state to another. The fecal pellets that make up the snow are rich in nitrogen and phosphorus. The dead exoskeleton is rich in chitin. Marine snow turns the water column into a three-dimensional digestive tract, where energy is extracted. As we descend further, past 3,000 meters, the snow becomes sparser, but more critical. Here, the water is calm. The snow falls in straight, vertical lines. It is silent. It is hypnotic. To a human observer, it looks like deep space, stars streaking past the viewport. But to a deep-sea biologist, this is not space. This is a diming table. We see bacterial colonies riding the snowflakes down, glowing with bioluminescence as they break down the organic matter. We see copepods hitching rides on the larger flakes, surfing the aggregate down into the dark, grazing on it as they fall. The snow itself is alive. It is a mobile microbiome. It carries surface bacteria to the depths, introducing new genetic material and new chemical pathways to the abyss. It connects the atmosphere to the sediment. It connects the wind that stirs the surface nutrients to the pressure that crushes the bottom dwellers. There is no separation. The fear of the deep often stems from its perceived alien nature, that it is a place apart from us. The carbon in your body, the CO2 you exhale, the plankton that created the oxygen you are breathing right now. Eventually, it all becomes snow. The bow, once proud, now rests in the abyssal darkness, draped in a ghostly. This constant rain creates the soft, thick layer of ooze that characterizes the abyssal plains. It is a blanket of nutrition. Without it, the monsters we fear, the fangtooth. They are the apex predators of a food web built entirely on dust. The monsters do not live in a void. This system does more than feed the deep. If marine snow were simply a catering service for abyssal scavengers, it would be a biological curiosity. But the scale of this phenomenon transforms it into one of the most critical mechanical gears in the planetary machine. Oceanographers call this process the biological carbon pop. Without this constant rain of debris, the Earth's climate would look radically different and likely uninhabitable for us. Here is the mechanism. In the sunlit surface waters, phytoplankton are microscopic engines of carbon capture. Through photosynthesis, they pull carbon dioxide from the atmosphere and lock it into their bodies as organic carbon. If they were to simply die and decompose at the surface, that carbon would be released back into the atmosphere as gas almost immediately. A cycle would be a zero-sum game. But marine snow changes the equation. Because the snow aggregates and sinks rapidly, it physically transports that captured carbon out of contact with the atmosphere. It drags the carbon down through the mesopelagic, past the bathypelagic, and deposits it onto the seafloor. This schematic illustrates the process of carbon sequestration, pulling emissions from the atmosphere and securing them deep within the geological crust. Once that carbon reaches the abyssal sediment, it is effectively removed from the global equation. It is sequestered. It can remain trapped in the deep ocean mud for thousands, sometimes millions of years. The deep ocean is the largest active carbon reservoir on Earth, holding 50 times more carbon than the atmosphere. The falling snow is the silent exhaust system of the planet, scrubbing the sky of greenhouse gases and burying them where they can do no harm. We often view the abyss with fear, a dark, pressurized environment that is hostile to human life. But in reality, the abyss is actively protecting human life. Every flake of marine snow that settles on the bottom is a microscopic victory in the regulation of our climate. The darkness of the deep is not a threat. It is a shield. Scientists estimate that the biological pump transfers roughly 10 gigatons of carbon from the surface to the deep ocean every single year. To put that in perspective, That is roughly equivalent to the annual carbon emissions from all human activity combined. While the ocean cannot sequester all of our excess emissions, the marine snow is working tirelessly to buffer the impact. It is a service provided for free by the dime. This adds a layer of profound tragedy to the potential collapse of ocean ecosystems. If we destabilize the plankton populations of the surface through warming or acidification, we don't just lose the bottom of the ocean, we set up the public. The snow stops falling, the deep starves, and the carbon stays in the sky. The deep ocean currents stir, bringing with them the golden flakes of marine snow. When we analyze the monstrous adaptations of deep-sea creatures, we now see their true purpose. They process this carbon, burying it deeper into the geological record. They're the custodians of the planet's chemistry. The terrifying vastness of the ocean is actually a massive, benevolent lung, breathing in our exhaust and exhaling a future. We began this journey by looking at the deep ocean as a place of starvation and eternal night. We feared it because it seemed disconnected from the world of light and life that we understand. But the marine snow reveals the truth. There is no disconnect. The ocean is a single, unified organism, connected vertically by a continuous rhythm of energy. What we perceive as death at the surface, the decay of a bloom, the molting of a shell, the waste of a whale, is simply the beginning of a migration. The energy does not vanish, it transforms. It sinks. It becomes the fuel for a vibrant, alien world that mirrors our own. Sirs, sunlight fuels the surface, sustaining the plankton below. But as we descend past the snow line, the true abyss roars. The fear of the deep is often a fear of the void, of nothingness. But science shows us there is no void. The water is thick with history. The darkness is filled with the falling remnants of the sun. So the next time you see footage of the pitch-black abyss, do not look for monsters lurking in the shadows. Look for the snow. Look for the delicate, falling proof that life is the paradox of the starving dark is resolved. The deep ocean is not a desert, but a garden fed by the sky. By understanding marine snow, we replace the planal fear of the unknown with a sophisticated appreciation for the planet's most elegant recycling system. We realize that even in the deepest, darkest trenches, life finds a way. Not by fighting the dark, but by catching the light that falls from above.